determine if a Class Roman II supply is inherently protected when manufacturer information is unavailable, several methods can be employed. Firstly, refer to the National Fire Protection Association 70, which is the National Electrical Code. Article 505 of this code provides requirements for Class Roman II supplies and includes information on inherent protection. Section 505.2 provides a list of inherent protection methods. This includes the use of low-energy circuits, which involve limitations on voltage and current. The use of a listed transformer or power supply is another indicator of inherent protection, as is the use of a listed power unit with inherent protection. Secondly, consult Underwriters Laboratories, or UL, standards. UL publishes standards for various electrical products, including power supplies. UL 1310, for example, covers Class Roman II power units and provides information on inherent protection requirements. These standards outline the specific tests and criteria that power supplies must meet to be considered inherently protected. Thirdly, carefully examine the marking on the device itself. Some Class Roman II power supplies or transformers may have a marking or label that explicitly indicates they are inherently protected. Look for markings such as Class Roman II or inherently protected. These markings are typically found on the device's label, near the input or output specifications. Fourthly, consider testing the device. In some cases, it may be necessary to perform testing to determine if a Class Roman II supply is inherently protected. This testing should be conducted by qualified personnel using appropriate test equipment. The testing process may involve measuring the output voltage and current under various load conditions to ensure they remain within safe limits as defined by relevant standards. Inherently protected Class Roman II power supplies are designed to limit both voltage and current to safe levels even under fault conditions. This protection is typically achieved through the use of internal components such as current-limiting resistors, thermal fuses, or other protective devices. These components are designed to automatically limit or interrupt the flow of current in the event of an overload or a short circuit, thereby preventing overheating, fire, or electrical shock. The National Electrical Code, or NEC, provides guidelines for the installation and use of Class Roman II power supplies. These guidelines are intended to ensure that the power supplies are used safely and effectively, and that they do not pose a hazard to people or property. The NEC also specifies the requirements for the wiring and overcurrent protection of Class Roman II circuits. One key aspect of inherent protection is the limitation of voltage and current. Class Roman II power supplies are designed to operate at low voltage levels, typically below 30 volts direct current or 42.4 volts alternating current peak. This low voltage level reduces the risk of electric shock. Additionally, Class Roman II power supplies are designed to limit the output current to a safe level, typically below 8 amps. This current limitation helps to prevent overheating and fire. When examining a power supply, look for certifications from recognized testing laboratories such as UL, Canadian Standards Association, or CSA, or other similar organizations. These certifications indicate that the power supply has been tested and meets the requirements of the relevant safety standards. The presence of a certification mark can provide assurance that the power supply is safe to use. The UL 1310 standard specifically addresses Class Roman II power units. This standard includes requirements for the construction, performance, and marking of these power units. It also includes tests to verify that the power units provide inherent protection against overloads and short circuits. When selecting a Class Roman II power supply, it is important to consider the application for which it will be used. The power supply should be rated for the appropriate voltage, current, and power levels. It should also be suitable for the environmental conditions in which it will be used, such as temperature and humidity. In addition to inherent protection, some Class Roman II power supplies may also include other safety features such as overvoltage protection, short-circuit protection, and thermal protection. These features can help to further protect the power supply and the equipment it is powering. When installing a Class Roman II power supply, it is important to follow the manufacturer's instructions and all applicable electrical codes. This will help to ensure that the power supply is installed safely and correctly, and that it will provide reliable performance. Furthermore, regular inspection and maintenance of Class Roman II power supplies can help to identify potential problems before they become serious. This can include checking the power supply for signs of damage, such as cracks, dents, or frayed wires, and testing the output voltage and current to ensure they are within the specified limits. Remember, if you are unsure about whether a Class Roman II power supply is inherently protected, it is always best to consult with a qualified electrician or electrical engineer. These professionals can help you to assess the power supply and determine whether it is safe to use. To summarize, the key methods for determining if a Class Roman II supply is inherently protected without manufacturer information are: firstly, checking NFPA 70, particularly Article 505. Secondly, reviewing UL standards, especially UL 1310. Thirdly, looking for markings on the device indicating Class Roman II or inherently protected. And fourthly, performing testing by qualified personnel using appropriate equipment. By using these methods, it is possible to determine whether a Class Roman II supply provides the necessary level of protection. Class Roman II power supplies are commonly used in a wide range of applications, including consumer electronics, lighting, and small appliances. They are often used in applications where safety is a primary concern, such as in toys and medical devices. The inherent protection provided by these power supplies helps to reduce the risk of electrical shock and fire, making them a safe and reliable choice for many applications. It's also important to understand the difference between Class I and Class Roman II power supplies. Class I power supplies typically operate at higher voltages and currents than Class Roman II power supplies. They also require grounding to provide protection against electric shock. Class Roman II power supplies, on the other hand, do not require grounding and are designed to provide inherent protection against electric shock through the use of low voltage and current levels. The NEC provides specific requirements for the installation and wiring of both Class I and Class Roman II circuits. These requirements are intended to ensure that the circuits are installed safely and that they provide the necessary level of protection against electrical hazards. When working with electrical equipment, it is always important to follow safe work practices and to use appropriate personal protective equipment, or PPE. This includes wearing safety glasses, gloves, and other protective gear as needed. It is also important to de-energize electrical circuits before working on them whenever possible. This can help to prevent electric shock and other electrical hazards. If you are not qualified to work on electrical equipment, it is always best to consult with a qualified electrician. These professionals have the training and experience necessary to work safely and effectively with electrical equipment. Understanding the principles of inherent protection is essential for anyone who works with or uses Class Roman II power supplies. By following the guidelines and recommendations outlined in this discussion, it is possible to ensure that these power supplies are used safely and effectively. This can help to prevent electrical shock, fire, and other electrical hazards. Remember to always prioritize safety when working with electrical equipment. Take the time to understand the risks involved and to follow safe work practices. This will help to protect yourself and others from electrical hazards. Additionally, consider the environmental impact of electrical equipment. Choose energy-efficient power supplies and dispose of them properly when they are no longer needed. This can help to reduce your carbon footprint and to protect the environment. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. If you have any questions or concerns about the safety of electrical equipment, please consult with a qualified electrician or electrical engineer. They can provide you with specific guidance based on your individual circumstances. Continuous learning and staying updated with the latest safety standards are crucial in the field of electrical safety. Make it a practice to regularly review relevant codes and standards such as the NEC and UL standards to ensure that you are following the most current guidelines. This will help you to stay informed about the latest developments in electrical safety and to improve your ability to identify and mitigate electrical hazards. In conclusion, determining whether a Class Roman II power supply is inherently protected requires careful examination and adherence to established standards. By following the methods outlined here, you can make informed decisions about the safety and suitability of these power supplies for various applications. Always prioritize safety and consult with qualified professionals when needed to ensure the well-being of yourself and others. Furthermore, remember that the field of electrical safety is constantly evolving, so it is important to stay informed and to continue learning throughout your career. This will help you to remain competent and to provide the highest level of protection against electrical hazards.